Welcome, everyone. It's the Crypto Lark, and I'm super excited to have on the show today Arthur Breitman of Tezos. Arthur, welcome.
Thanks for having me.
Now, let's start off with the obvious question. Where did you come up with this crazy name?
Oh, Tezos. Well, no, Tezos is really how they called smart contract in ancient Greek. That's the answer. Of course, at the time when they did blockchains, the blocks were physical. They were made of marble. They would have to cut them, and the chains were made of bronze because there's no steel yet. And so it was very very slow process.
If you think transaction times are
So
bad now, guys.
yeah, no, that was terrible. But realistically speaking, like I like that it's a short word and it's a word you can Google fairly easily. If you search it, it's the only thing called Tezos in the world.
Yeah, well, uniqueness is a big feature when it comes down to it. How many, I don't know, John Smith companies are out there? A lot when it comes down to it. Now, for anyone who's not familiar with what you do, can you give us the short version? What is it?
Yeah, so Tezos is a cryptocurrency. I would say it's in the same vein category as cryptocurrencies like Bitcoin or Ethereum. It also gives you the ability of writing smart contracts, so like Ethereum does, where you can kind of like program the money. But I would say one of the things that Tezos is mostly known for is the self-amending aspect. And what that means is the platform provides a way to get subsequent version added. So it can get better. Like you have different version of Windows, of Linux, of Android. They increment. And the idea is like, how do we do this in a blockchain where there isn't a single person who can say, well, that's the next version, right? And
Mhm.
that's what it attempts to do.
Yeah, as we've seen, the forks in Bitcoin, for example, have been so divisive and so destructive to the community. It hasn't been good at all. So any avoiding that process, I think, is really important. We're going to get into more on governance in a moment, though. I want to start off with some of the features of Tezos. So formal verifications. This sounds like a big scary thing, but can you explain in a very simple way what are formal verifications and why are they important?
Right. So first of all, formal verification is not a feature of Tezos. It's something that I would say all the people who've been working on Tezos really have in mind, and that's something that we try to make easier, right? So formal verification is, when you write a program, very often the program can have a bug, right? And the effect of the bug can be more or less bad. So if I have an app for ordering pizza and once in 1,000 times there's a bug that means the pizza is not going to arrive, that's not a very big deal, right? You fix a bug and then you correct it and maybe someone didn't get their pizza. If you're writing software for a rocket, for example, then it gets a lot more important because these things are very expensive. And you laugh, but there's been at least I know there's two events of rockets blowing up because of software bugs. One is the Ariane rockets, that's the European rocket program. And it had a counter that was measuring how fast the rocket was accelerating away from the Earth. And it went so fast that the counter looped around because, when you have numbers in programming, they just loop around. So it looped around and all of a sudden it was like, I'm accelerating, I'm going really fast, I'm going really fast. And then all of a sudden it's like, oh no, I'm actually decelerating. I'm going very fast towards the Earth because the number turned negative. And so the rocket decided, it's like, no, I'm pointing towards the Earth, I need to correct. And it corrected by turning in the wrong direction, it
Oh
blew up.
no.
There's another example also with Lockheed Martin and NASA. One of them was counting force and the other ones was counting the force, the pressure in Pascal, Newton per square meter, and so just the difference of units and some. So in this industry, in aerospace, they've developed techniques known as formal verification. So they're really techniques to make sure that this type of things don't happen, or at least to have more powerful techniques. So what are the ways we have to avoid bugs? Well, the one way is that we could be very clever and never write a bug, right? We write the program
Well,
perfectly the first
obviously,
time.
right?
That would be great. But it's really difficult. We can't really do that. It's not like humans can't really do that. The second thing you can do is do a lot of testing, right? So you're going to have many tests. You're going to try your program in many circumstances. And if any of the tests fails, then you say, okay, I have a bug and you can fix it. One of the example is there's a database called SQLite, and they have millions, and that's many times more of line of code for testing than for actually like programming the database. So there's a massive effort in testing. And the third one is formal verification, where you say, I'm going to look at this program as a big mathematical equation, and I'm going to make it, and I'm going to make proofs about it. I'm going to make mathematical proofs that say, okay, if this equation holds, then this other equation holds, and I can prove that, the rocket's never going to go down, for example. So you try to prove properties like this. And you can still get it wrong because maybe you don't think of checking the right properties, the one you really care about, but it's a lot more powerful than testing as a technique. Now, the downside of formal verification is that it's a lot of effort, right? It takes, and historically it has taken specialized team, specialized knowledge, specialized tool software, and a lot of human touch to be able to do that. But in recent years, it's gotten a lot better. Right? There's a lot more tools which are available. It's a lot more automated. There are a lot more powerful techniques. So what Tezos attempts to do is to try to hitch to this to hitch itself to its wagon and say formal verification is going to grow bigger. It's going to grow better. What can we do to benefit as much as possible for this type of from this type of technology? And a couple things. So one is the entire code base of Tezos is written in a programming language called OCaml. And the nice thing about OCaml is that it's a programming language that was designed by people working on formal verification. The entire point of the language was to build, the language was designed to build another language which itself could be formally verified. So there's a lot of links between OCaml and formal verification. If you take, for example, F-star is a programming language. It's built by INRIA and by Microsoft, and it lets you do automated formal verification. Well, it turns out if you write F-star, you can have, when you compile it, you get, what do you get? You get OCaml, right? So it's very nice to have this. It lets us, for example, use formally verified cryptographic libraries inside of Tezos. And so, this is not to say that Tezos is not itself formally verified. That's, I would love to see this, but this is, a multi-year or even decade endeavor to verify a code base like this. But the ties make it really the ties make it a very, very good give it a head start if you want in order to do that. The second thing is the smart contract language of Tezos called Michelson. So if you write smart contracts for something like Ethereum, you have a language like Solidity, and then Solidity gets compiled down to EVM, which is some sort of which is a kind of an assembly language. So if you look at EVM, it's just bytes, it's not human readable. If you look at Solidity, you can read it, but you don't always know the connection between the two. If I read something in Solidity where it's easier to understand what's going on, it's harder to write, right? It's harder to write something in Michelson than in Solidity, at least for now. But you have the benefit of getting a stronger confidence in what you've actually written. And also, and part of the reason it's hard to write is that the language is designed a little bit more like mathematical equation. But the benefit of doing that is that if you want to use the tools of formal verification on this language, then you're going to have an easier time. Formal verification. Yeah.
Do you think that using Michelson's actually? It's just interesting for me. I mean, there's so many different blockchains, and so many are choosing to use different languages, or in terms of being a developer, right? Let's say I went off and I learned some of the really common programming languages. But now if I want to, build something on Tezos, I have to use Michelson. If I want to build something on Ethereum, I have to use Solidity. If I want to build something on Cardano, I have to use Haskell. So are we kind of building silos here with the languages? Is it a good idea to have a language that is not used by another blockchain, I suppose? And what are the advantages and disadvantages of that?
I think I think it's early anyway. I'm sorry, the video was breaking up a little bit. I think it's early a little bit. And so, we'll see some convergence. There's an interesting convergence happening with WebAssembly as a low-level language. And certainly that's something that Tezos could evolve to in the future. And that would mean basically taking Michelson and saying, okay, instead of directly taking the Michelson code and executing it, we would compile it down to a lower-level language. Right, and you can do that with you would want a certified compiler so that you know exactly that your compiler is going to translate accurately between one and the other. So these things are not set in stone, and this thing can move. And different languages have different advantages for different projects. So it's good that there are many experiments around, and we'll see what.
Yeah, well, that's it. It's a lot of experimenting going on right now in the blockchain space, and that's a good thing. It's a good thing. The best ideas will rise to the top, right? Now, I want to move on to liquid proof of stake, and I guess the proof of stake model overall. But what is liquid proof of stake to start off with?
Right. So liquid proof of stake was a nickname that was given to the consensus system in Tezos, and the reason that the term was coined was because there's delegation in Tezos, and some people would say, oh, it's DPoS, right?
Mm-hmm.
And DPoS is that's a model that's Dan and Reimer used for BitShares and for STEEMIT and for EOS and all of these different projects. But this is a very different thing in the sense that you do have some delegation in Tezos, but it's optional, right? Mm-hmm. So you don't have a fixed set of people who can participate. Everyone can participate and create and create blocks in the system. There's not a set number. Essentially, one thing that that's important to distinguish, and Emin Gutsir talks about that, and even early on, one of the first person to talk about Bitcoin, Ben Laurie, in his first article on decentralized currencies are probably impossible. One of the things they really outline is you have to make a difference between your Sybil resistant mechanism and your consensus algorithm. And your Sybil resistant algorithm is who gets to take part in consensus. Mm-hmm. And that's the biggest question. When you have a decentralized network is, you say, okay, we're going to get an agreement, but between whom? And so in Bitcoin, the choice is made anyone who has hashing power. You have 1 gigahash per second. That's your voice in the consensus. And in proof of stake, you try to say, no, let's try to make it either you have 1 token or you have some tokens which are that you've locked up, but you derive it from the token themselves. And that's who is allowed to take part in the consensus. And then the second thing is how do you actually do consensus? And when people talk about LPOS in Tezos, I think they really mean the former, which is who gets to participate. Mm-hmm. And in Tezos, it's a bit of a mix because anyone who has token can receive rights to create blocks. But if you do get this right, in order to exercise it, you need to take some tokens and you need to lock them. So it's a combination of things. And overall, empirically, it's done fairly well because there's now 450 different block producers on Tezos, different bakers, big and small.
I was going to say, they're not block producers. They're bakers. This is Tezos.
Right, they're bakers. They're bakers, exactly. Baking is block producing.
That's great. I love it. It's different. Like, what inspired you to go, you know what? Block producers, staking, block producers. We're going to bake and with bakers.
Yeah, I think it's one of the engineers that was working on a project who came up with a name. I think it was Benjamin who came up with baking. And we're looking at different words. So mining, the problem is that mining is about hash power. So you don't want to mine the block. And NXT many years ago had forging. I like forging, the idea of you make it visually works. But the problem is that forging, maybe it sounds like forgery. You're making something fake. So I didn't like forging for that. Minting was one, but you're one typo away from mining. And minting is all about creating tokens. And I don't think that block production and token creation are the same thing. They don't have to be linked. And so I didn't like minting either. And baking, the project has French roots and French love their bread. So why not baking,
I was going to make the joke, but you beat me to it. It's great.
No, but it's real. I mean, it's not a coincidence.
That's amazing. Well, it does set you apart, and it just kind of, represents that everyone puts their ingredients together and then we bake something that comes out the other side there, so that's good. That's great. Now, ZK snarks, there are rumors that this is going to be coming to Tezos in the near future. Is it going to be coming? And if ZK snarks are coming, why were ZK snarks looked at over, for example, ring signatures?
Right, that's a good question. So what might be coming in Tezos, as opposed to ZK snark as a whole, is specifically the Zcash circuit, the sapling circuit from Zcash. So Zcash released a new circuit when they can make very efficient proofs and they can have very efficient private transactions. And so what got merged into the Tezos code base is bindings to that. So we can call this library from OCaml. And yeah, that might come in the Tezos protocol if the stakeholders of Tezos, if the people who hold their token decide that this is the type of change that they want in the platform, then yes, that could be coming fairly soon. Because to be honest, this is standing on the shoulder of of giants, because this is an amazing work I think that the Zcash team has done, and benefiting from that is one of the beauty of open source.
Yeah, well, the open source community is amazing. Obviously, a lot of people have been taking advantage of, the great work that the team over at Zcash has done. A lot of different major cryptocurrencies are implementing ZK Snark technology, or different levels of it, or whatever it might be. And here, you guys are working on
Yeah.
potentially looking at sapling, right? But of course, the stakeholders actually have to vote on that. So yeah, very very interesting. I think that any major blockchain without privacy features, it's just not. It's not. You're gonna be uncompetitive because everyone else is gonna have it, right? You can say, "Hey,
Yeah.
we're the only guys without that technology." Well, why? Right? It'll
I,
kind of become
I,
a
I
standard.
think everyone needs it. Yeah, yeah. And so
Absolutely.
you're asking why doing this as opposed to something like Monero, for example. And one of the example I like to give is, let's say, for example, we live under some oppressive regime, and and you sell podcasts. You sell recordings of a podcast under the code, or rather on the internet. And I'm the secret police, and I want to know who you really are. And so what I do is I buy 3 or 4 different podcasts from you, and I use something like Monero, for example, with ring signatures to do that. And then you go to an exchange to cash out, right? But then I'm the secret police, and I go to the exchange and I say, if look at these UTXOs, that's the one that I actually spent when I bought this podcast. And if it so happens that the same person, when you're going to spend with them, you're going to say like, oh, I could be spending any one of these 5, and I could be spending any one of these 5, and I could be spending any one of these 5. But if it so happens that, all the ones which were, which were controlled by the secret police all happen to be with the same customer of the exchange, they can find out who you are. So I think ring signature, it works. I think you can do some network analysis. You'll be fairly protected if against a passive attacker. And by a passive attacker, I mean someone who's just looking at the network, and they're not doing anything. They just look at what's going on. It might be hard for them to find you. But someone who's actually actively looking for you and can send you payments and look what you're doing. That's, I think you have less privacy. So I think you're getting more privacy from the snark thing.
Certainly ZK Snarks have set themselves up an industry standard, even though ring signatures is amazing technology as well, right? So it's kind of, I guess, about approaches and where you think it could be going. Now, I really want to talk about the governing, because this is what it all comes down to for Tezos. It is going to be what the stakeholders want it to be, I guess, in the end. It's kind of, are you worried that the stakeholders might come up with bad ideas?
It's it's possible, but I am more worried that I am more worried about having a single point of failure than having the occasional bad idea. Come on, it's okay to make mistakes. It's what's important is they don't have catastrophic IDs. But I would rather protect the network against catastrophic risks than try to make the best decision all the time. It's kind of like in a democracy, you might make mediocre decisions, right? I don't think that just because you're voting, people are magically gonna say like, oh, we're voting and there's a wisdom of the crowd and we pick the best person. But you're not gonna pick someone horrible. Whereas in a dictatorship, maybe you have a great dictator and they know everything and they do everything right, and then that's better. But then they get replaced by someone else, and then you get like something terrible. And in fact, if you look at dictatorships in democracies and GDP growth, you will find typically the main difference is a variance. So the data variance in their growth, whereas democracies will have something a little more stable. So if you really want to protect against a downside, I think that against a really bad downside, I think having governance is a good protection.
It's very interesting, the whole concept of on-chain governance. Now, in Tezos, is it one Tezos equals one vote, or do you have to have, the 10,000 staking actually running, being a baker, can only bakers vote, or can anyone vote with any amount of tokens?
So in the current model, the only way you vote is by having what is called a roll, and a roll is a set of 10,000 tokens. So it's not that there's a minimum; it's just that it's rounded down to the nearest 10,000. So if you had 25,000 token, for example, and you were a baker, you would get roughly 2 votes. And right now it's a baker's 2 votes. However, there's some interesting proposal for changing that. And one way to change that is to say, well, let's the bakers vote, and then let people change their delegation. So if I don't like the way that my delegate voted, I can say, you know what, I don't like your vote. I'm going to move my delegation to someone else so that it's their vote that counts. Kind of like liquid democracy. And so it's the idea of like, so any system where you're going to have voting, you have to deal with the problem of apathy. You know, people not voting.
Yeah.
And there's been some carbon votes in Ethereum where very few people vote. Many systems like this have very, very little participation. But if you make the bakers vote, the nice thing is bakers, by definition, they're kind of paying attention to the network because they're actively participating in it. And so you're more likely to have the bakers actually care about the votes. But if I'm not a baker and I care about the votes, I can still say I'm going to go to another baker because I don't like the way that you're baking. So I think you kind of get the best of both worlds. I'm doing this.
Yeah, and that's really cool because I can imagine there'll be people who don't have that role of 10,000. Maybe they've only got 1,000 Tezos tokens and they're delegating. They I just don't like the way
Yeah.
this guy votes. You know, this is not the network I want to see, and so they can then change their power. And I think much like what Dash did with their master nodes, the
Yeah.
people who have a lot invested in the network are the ones making the decision, and there can be proponents against that saying, oh, it's the oligarchy, or it's like the Greek city states again, or whatever. Well, we're not
Exactly.
we're not governing a country here, we're governing a platform, and these are the people who are actually invested in the platform literally with their money but also with their time when it comes down to it, and they're the ones who want to see the future of the platform succeed. They're invested in making that happen, so it's makes a lot of sense to me that these would be the people who would be voting on the future of the platform.
Absolutely, and I think that that's what you see. You know, the bakers are very involved. It's not, like you say, it's not just their money. It's their time. It's, many bakers have employees. They actually have data centers. So there's a lot that's going on from all these parties to make the network function. Although for the as far as the role size, one thing I'd like to point out is, the reason it's 10,000, it's really a technical reason for data. It's a database reason. So there's between 700 and 800 million tokens of Tezos on the network. So if you have 10,000 tokens per role, that means you have about 80,000 roles, or at most, and you have literally a table that maps for each role. So there's a table with 80,000 rows, and let's say, well, this role belongs to this person, and this role is controlled by this person, and so on and so forth. And so if that database can be made more efficient, if it can be optimized, and right now it's not really optimized, if you can optimize it a little more, then you can probably get it down. I don't think you get it down to like one Tez, for example, but you could, at least a factor 10 is probably doable. The idea is that it should be negligible. It should not be an obstacle that you need that much.
Yeah, and it's right now looking at Tezos, it's a little bit cheaper to get a role, right, in the current market
Oh yeah,
situation. But I mean, in 5 years' time or something like that, we might see a situation like happened with the Dash master nodes, where all of a sudden it becomes very unaffordable to to be a baker. Basically, people who got in at an earlier stage, they're able to afford to be bakers, or people who are millionaires are able to afford to be bakers. I mean, even at the height of the madness with Dash, we still saw new master nodes coming online, so people were spending $500,000, $800,000 to get a new master node. So that'll keep happening too, especially as it becomes incredibly profitable to be a baker, right? There's also that monetary equation as it continues to grow. So that's something to keep in mind too. Now, the amendment process itself, this is what we were talking about a little bit earlier when we were talking about the idea of avoiding hard forks, right? So this is about getting all the stakeholders to come together to agree on what's going to happen. Now, do we need a plurality? Do we need like 51% of the bakers to agree on something for it to happen?
So in the current model, you have there's many hoops that need to jump through. So the first phase is you can have many proposals, right? And so you have many proposals, and literally every baker can upvote the proposals they like. So they choose all the proposals they like, and they upvote them. And that's just to whittle it down to a single one. Then once you have that one proposal, you submit it to a vote. Okay, and for that vote, you need a quorum of 80%. That means 80% have to voice an opinion. And then among those 80%, you need an 80% of a yes. And then you run a test net, and then you run a second vote. So there's a lot of hoops to jump through. It's meant to be very changed. So as the protocol can be changed, so can the governance procedure. It could be tightened or it could be loosened. But the idea is that the point is not oh, there's 60% of the network that ferociously wants something and 40% that ferociously wants something, and where is this threshold going to be? Overall, it should not be very sensitive on the threshold. In some sense, the debates in the community should happen before a proposal is made. Like the proposal is made once you have rough consensus that this is probably what should happen, and once you do that, then you can make those proposals. One question I often get also is, well, what happens if people are disagreed with it, or can't they fork? And of course, people can always fork. That's Tezos does not by itself prevent fork, but a lot of times people don't really want to fork. A lot of times I see people say they're going to fork as a strategy to try to steer the direction. They say like, well, you better do this, because if you don't do that, then I'm going to fork.
That's it. It's almost used as
like,
a threatening tool.
And then now they have to, and then they have to fork. Whereas here, you can say like, well, clearly it was shown that it was a process for getting the decision, and the process was met. And so, sure, you can fork now, but you're gonna have a hard time claiming that your fork is the one true version. That
when 98% of the community voted against it, or for it, and you're the only one voted against it.
And all these forks, there's always some idea of legitimacy behind them. Ethereum Classic is the real Ethereum. No, Ethereum is the real Ethereum. Or Bitcoin Cash and Bitcoin, it all plays to like, I'm the real one, I'm the original one. And that's because because I think what determines the value of this network and why people are interested in them is whether or not they become this point of focus. And it doesn't necessarily have to do with the technology. A lot of times it has to do with perception. And so keeping the perception that, no, I'm the real one, I'm the central one. Well, not in the centralized, but I'm the point of focus. That's what matters. And that's what you get by having a governance procedure.
Now, I want to move on to the foundation a little bit. So the Tezos Foundation's been putting out some grants. Can you say any of the grants that have been given out? What are the projects? I mean, who are they looking to fund with these grants?
Then I think you should have someone from the foundation to answer that. There's some cool people there. I can recommend. There's a group of people I know I can recommend, but they have a cool website, Tezos Foundation, or Tezos.foundation, where where they list the type of stuff that they're interested in funding. In terms of grants, well, one of the grants they've given was to a group called Cryptonomic in Brooklyn, and they're working on a wallet called Galleon. So the Galleon wallet is a desktop wallet that you can use for delegating and using your funds with Tezos. So that's one thing. Another one they gave is to a very prolific developer who also lives in New Zealand, named Stephen Andrews. And Stephen has done many projects in the Tezos community, including Tezbox, which is also a wallet which comes in many different forms, and is working on a wide variety of projects. So these are some of the efforts that they've been supporting.
Very cool. A lot of the nuts and bolts sort of things, like having a great wallet, for example. Like you cannot overstate how important it is to have a good functioning wallet for your blockchain. I've seen so many wallets that only work half the time.
Yeah. And I'm also there's also several mobile wallets in development for Tezos, and I'm always surprised how few mobile options there are for wallets in most app stores. It's in general pretty limited, even so, most people are always on their cell phone now, more so than on their browsers.
Well, especially if you want to use it as currency. I mean, you go to a shop or something and you want to spend your cryptocurrency. You're not going to drag your desktop in with you. It's very impractical.
Absolutely. But you're right about mentioning nuts and bolts. I think it is very much a nuts and bolts phase for Tezos. This is a phase where all the tooling comes to life, all the I know the different baking services establish themselves. We're really very much in that phase.
Now, there's been a commitment to train 1,000 new developers how to use Tezos in 2019. Uh,
Yeah, I
who
read that as well.
who came up with that initiative, and do you think they're going to get those 1,000 new people trained?
Uh, I th- I think it came from the Tezos Foundation. Again, you should really have them on the show, and I think they can explain. But what I can say about Mickelson is that it's a different language from what you might be used to if you use like normal programming languages. It's a lot closer to something like Bitcoin script, for example, than something like Solidity. And it can be daunting at first, but you realize oftentimes that you're going to spend so much time verifying that you're, triple checking every line of your program anyway when you write a smart contract. It's not like you're writing a large piece of code and oh well, I'm mostly sure that everyone works well. You write a smart contract, you're going to want to verify every single line, and if you're going to do this anyway, then you'll find that writing in something like Michelson actually is not a big hurdle. But it is very different from the way that people may be used to programming languages. There are efforts, so there are several high-level languages that compile down to Michelson. There's Spy, there's JuviX Liquidity, and there's a couple more that I heard about which are in development. So I don't think people will necessarily have to use Michelson, but a lot of big projects and anyone writing a big serious contract might probably want to look at Michelson directly. The other thing that I want to, oftentimes people are under the impression that you have to write a smart contract in OCaml for Tezos, but that's not the case. OCaml is just like what the what the blockchain itself is written in. So it's kind of like Ethereum is written in Go and Polkadot is written in Rust, and so we're written in OCaml, but the the smart contracts themselves are not.
Now, I got one final question for you. I know, of course, you're very busy with actually developing the blockchain and making sure it's all running correctly, et cetera, et cetera. But let's just say you had a lot of free time on your hands and you wanted to make a DApp or something like this on top of Tezos. What would you make? What do you think would be an amazing project to build on top of it? What would be your dream project to build on top of Tezos?
Oh, well, I think that my co-founder and wife Kathleen is doing a really cool project on Tezos. She's building a collectible card game on the Tezos platform, and so I'm really
Mm.
excited about that. I think gaming is a really cool use case for this platform, and I'm really looking forward to that.
That's really exciting, actually. There's one based on Ethereum. I got some cards for the other day, just for fun. I used to play collectible card
Yeah.
games back in the day, but I think the nexus of gaming and blockchain coming together, especially for things like collectible card games, like it's going to be absolutely huge. So very cool to see that happening. I'll definitely be keeping an eye out for when that comes out and go over and grab some
Yeah,
cards.
absolutely, absolutely. The other thing I really like as a use case is insurance and micro insurance. It's something I've been passionate for a long time, way before I even got interested, intrigued with currencies or smart contract platforms. I like the idea of having small insurance contract where there's a clear, there's a clear way to get paid. And my experience with this is, have you ever bought the travel insurance when you like get on a plane and it says like, oh, add insurance for $30, or you have
Hmm.
to click the other one that says like travel without insurance, in red.
Oh,
So have you ever tried to collect on one of those?
I have never had the bad luck of having to try to collect on one of those.
So I have once, and I had like like completely legitimate reason to collect, and I tried to, and after 6 months I gave up. I would send an email, and then another 2 weeks pass, and then they say, oh, you need this document, and I said like, well, look at the terms. I don't. I'm like, oh yeah, you're right. And then they send me to someone else, and after 6 months of just emails and emails and emails, they just wouldn't pay. So I'm not gonna go out and sue them for like $200. That's not interesting. So
And this is what they
it's like,
count on.
yeah, yeah, and having the ability to see clearly in a smart contract that what I'm going to get those $200 if this condition is met, then that's very valuable, and I'd like to
Absolutely.
see that. And
Yeah,
the cost of claim processing and everything can be much smaller, so you can insure a lot more things that normally would be very expensive to insure because there's a lot less friction.
yeah. The use cases for that are, near limitless. Like, okay, I'm gonna get in this taxi. Like, if I'm gonna insure myself that if there's a wreck while I'm in this particular taxi, or if I'm late getting to the airport or whatever, on and on and on the use cases go. So, very, very interesting. Very, very interesting.
Exactly.
Well, definitely very exciting times for Tezos. I know I've been watching the project excitedly and will continue to do so. So, Arthur, thank you so much for coming on the show today and telling everyone a little bit about what's going on over at Tezos. And anybody who wants to find out more information, there are links down below. Of course, you can go check out the website or the foundation or any other relevant links to Tezos. So, Arthur, thank you so much.
Thank you so much for having me.